Do you want your machine learning algorithm to answer a yes or no question? A question like, is that a picture of a cat? Will that bank loan default? Then you might need a sigmoid function. Today's video is a slightly technical one. For this video, we're going to assume that you have some basic understanding of math functions and graphs. So if I say something like f of x equals x and I show a picture of a line, you know what I mean. This is an image of a sigmoid function. As you can see from the graph, as x goes to being a very negative number, the sigmoid function approaches 0. And as x goes to being a very positive number, the sigmoid function approaches 1. At the 0 point, the sigmoid function sits kind of in the middle at 0.5. If you're trying to get a true or false answer, you don't want your sigmoid function to be at the 0 point. The sigmoid function comes in handy when you're building a neural network because it generates an output that's either close to 1 or close to 0. So this is useful if you're trying to create a true-false output of a neural network. We can take that value, and if it's close to 1, we set the result equal to true, and if it's close to 0, we set the result equal to false. Hence the reason why a sigmoid function is helpful if you're trying to answer a yes or no question. Because the function deals with the answer that's generated by the neural network, we tend to attach the sigmoid function as the activation function of the output layer of your neural network. Okay, I've just used a lot of new terms, but in case you're new to this, let's go through them one by one. First and foremost, neural networks. This is a picture of a neural network. And as you can see, on the left-hand side, that is the input layer. The input layer represents the data features that input into the model to get the answer we're looking for. So for example, if we're trying to determine if a picture is a picture of a cat or a picture not of a cat, what the input would be to that model would be a whole bunch of pixel data of pictures of cats and not cats, like lots of pixels. And if we're trying to figure out if whether or not a bank loan would default, you'd have lots of time series data of interest rates and debt to income ratios and any other valuable economic data that you could throw into that model. That's the input of the neural network. Now the middle section are called the hidden layer of the neural network. And the interesting thing about that is it's not really hidden at all. You can see it. It's just right there. The reason why it's referred to as the hidden layer is that the output of the nodes of the hidden layer don't really correlate to anything humans understand. That is to say, the output layer gives us a result that has meaning, but the outputs of the hidden layer just feed other hidden layers, or they feed the output layer to give us the answer we're looking for. So the hidden layer, it's not really hidden, it's just right there, but the results that come out of it are hidden from our understanding, if you will. So one or more of these nodes will feed the last part of the model called the output layer. The output layer is where we get an answer that has meaning for us. And generally speaking, the output layer is the only place where you would attach a sigmoid function. This is a little bit advanced, and I'll probably go into details more of this later, but the other layers, you would have something called an activation function. It just wouldn't be the sigmoid function. You'd probably want either a tan h, which is a sigmoid function shifted down, or you'd want something called the ReLU, which is like a step, like a flat line and then a line going up. Those functions, it's like f of x on the right side and just x equals 0 on the left side. That's the ReLU. And see, those activation functions are useful in the hidden layers where we're not trying to get an answer we understand anyways. So we could use those activation functions. But where we're trying to get a yes or a no, we would drop a sigmoid function in. So how does a sigmoid function work? Let's take a look. So say we trained a model with 700 million pictures of cats and also pictures of not cats. And we've run this model and we give it a picture it's never seen before, and it gives us a result. The model comes back with a number like 423,792. Well, what does that mean? Is that a cat or not a cat? So what you do is you take the output of the model, you run it through a sigmoid function, and it turns into something very close to 1. And because it's very close to 1, you say true, therefore it's a picture of a cat. Okay, let's learn how to implement the sigmoid function. So for this, we're going to fire up Jupyter Notebook, and we're going to use NumPy to generate a real example of a sigmoid function. All right, here we are in Jupyter Notebook. Okay, first we're going to import NumPy as MP. That's always your first step when you're using NumPy to do things. In this case, we're going to be doing some exponentials, and we need NumPy because it's a little quicker than the math library. So now we're going to define a new function with the def keyword. We'll call it a sigmoid. So how do we actually make a sigmoid? So in this case, we're going to say 1 over 1 plus the exponent of negative z. Now, why does that work to give you a sigmoid function? Let's think about it. As z becomes a very, very large number, then the exponent of this negative number is going to be very small. And so as a result, you're ending up with 1 over something very, very close to 1. So you end up with the 1. As z becomes bigger and bigger, the answer gets closer and closer to 1. And if z is a really small number, then the negative exponent of z becomes a really big number. Something taken to an exponential power of a negative number is a positive number, and that makes it a large number. And you have 1 over a very large number basically is 0. 1 over a million is 0.00000, right? So the bigger that exponential gets, the smaller the answer is. So when you have a big negative number, the sigmoid goes to 0. When you have a big positive number, the sigmoid goes to 1. So that's how the sigmoid works. It's 1 over 1 plus the exponent of negative z in this case. In this case, we're saying f of z. Let's test this out. We'll make a cell, we'll insert a number. Let's pick a large number like 1,000. And sure enough, the sigmoid ends up being kind of close to 1. We'll print that result out. Now let's try it again. We'll make a negative number and print that out. All right. So we kind of proved that a sigmoid can work. We've got a little function that we've defined called sigmoid. Now let's think about something that's kind of boring, but also always worth considering. How do we want to document this? To have this sigmoid function documented up well, so one of the neat things about Jupyter Notebook is you're able to use LaTeX. And LaTeX is a very, very powerful text processing. It's like a text editor that's very powerful for mathematical functions. It's been around for a really long time. And everybody just kind of jumps right into using Markdown on Jupyter Notebook. But give LaTeX a shot. It's kind of fun and it's interesting. Here's what you would write in LaTeX to create documentation for the sigmoid function. And it ends up looking really nice. It ends up looking, it's like as good as mathematical notations can look. That's something to keep in mind. You're gonna have a little edge over other folks if you really know how to use LaTeX in your Jupyter notebooks. So I hope you enjoyed this video. Please consider liking and subscribing. And if you want to hang out to the end, there might be something fun. But if not, please smash that subscribe button and feel free to leave a comment if there's anything else you'd like to learn about data science, or if you want me to dive in deeper into neural networks. That's what I'm looking forward to doing. All right, thanks. Thank you for staying to the end of a video about the sigmoid function. That is very cool of you. Whoever you are, I guarantee you're a cool person. Since you're a cool person, let's have a little bit of fun. Just in the end here, I want to show you my process for kind of marketing and generating an image for this video. And as I've done in the past, I like to bounce things off GPT-3 just to see what ideas it comes up with. So here I've got a chat. I'm using GPT-3 chat now because that's a really easy interface. And for a little while, I think it's free. So I asked it the question, could you review a script I wrote for a YouTube video? That's me typing. And here's what GPT-3 said back. I'd be happy to review your script. Please go ahead and share it with me and I'll do my best to provide feedback and suggestions. Keep in mind that it's always a good idea to proofread your script and make sure it is clear and well written before filming. Also, it can be helpful to practice reading the script aloud to see how it sounds and to identify any awkward phrasing or pacing issues. I gotta say, I still get a little thrill when I think about the fact that it's a computer that actually answered that literally a computer said that to me just right now. That still gives me a little bit of a thrill. Maybe I'm just easily amused. I don't know, but it's amazing to me that a computer can do that. So here's what I did, and I'll just explain it to you rather than showing you, because I have another YouTube video that shows you. What I did was I rendered my video to an audio file, and I used the Whisper AI. It's an open AI library called Whisper, and I used it to transcribe my video. So I took that audio transcript of the video, and put it into this chat interface. And I don't need to repeat this because you've seen it already. And here's what it said back. Your script provides a detailed explanation of the sigmoid function and how it is used in the context of building neural networks. One suggestion I might have is breaking up the script into smaller chunks. Overall, it seems like you've put a lot of effort into creating a thorough and informative script. And with a few tweaks, it could make for a great video on the topic of the sigmoid function. It's like, that's a computer telling me that. It's amazing. It just blows my mind. So then I said, thanks. Any recommendations on what to call the video? Could you give me a few ideas? And it said, sure. Here are a few ideas for potential titles for your video for the sigmoid function. Understanding the sigmoid function, a beginner's guide. The sigmoid function in neural networks, what you need to know. Mastering the sigmoid function, a step-by-step guide. The sigmoid function explained, how it works in machine learning. And number 5, the role of the sigmoid function in artificial intelligence. Yeah, that's probably better.